This lesson is guided by a module. If you want to get the copy of the module, I've linked it in the description. Lesson 1. Introduction to Sets. A set is a collection with a common property, and the things we put in the set are going to be called elements. So let me just say this defined word later. So spoiler alert, it's going to be elements. So for example, here we have a set of clothes. A hat, a shirt, a jacket, a pants, and so on. These are what you're going to be calling elements. And let's move on now to universal set. Universal set is question bound. Everything that is going to be related to the question, that is our universal set. So if our question is going to be even numbers, then our universal set would be even numbers. If our question is all about the English alphabet, then our universal set is the English alphabet. A universal set is denoted by a capital U, like this example right here, where the universal set is vowels. Next, we have finite and infinite set. Looking at finite set, this is countable. Every element in that set is countable, meaning it has an end. So if you look at this example, set P is 0, 3, 6, 9. This is what you call an ellipse, which means it's going to continue that pattern until you get to 99. So it ended at 99, meaning even though you don't see every single element, it ended, meaning you can count all of it. Next, we have set Q here, where we have a set builder, A, such that A is an integer where it is between 1 and 10. So if we're going to rewrite this, Q, it is going to be between 1, so we don't start at 1. We start at 2, 3, 4, 5, 6, 7, 8, and 9, since it is between 10. Then we have a set of all English alphabets, which is basically countable. If it's not countable, then it is an infinite set. If we look at the examples here, a set of whole numbers. W is equals to 0, 1, 2, 3, 4, ellipse, and it doesn't end. So it is infinite. Then we have the set of all points on a line. We know from geometry that a line consists of infinitely many points. And a set of all triangles, there is an infinite amount of triangles. Next, we have the null set, which says that our set is empty. If we look at the examples here, the set of dogs with 6 legs, unless that dog has been washing in a radioactive bath, I don't think we will have a dog with 6 legs. So this is a null set. There's no such thing. A set of squares with 5 sides, that's impossible because a square only has 4 sides. It's in the name. A set of cars with 20 doors, you can argue, yes, but it's not reality. Then we have a set of integers which are both even and odd. There is no such number. So all of these are in an empty set, or you can use this symbol. Next, we have the subsets, which is basically a set within a bigger set, but the whole set itself can be a subset also. Here, we have an example. If set A has X and Y in it, and set B has X, Y, and Z in it, then A is a subset of B, meaning the set of A is just inside of B, which is, yeah, because this is set A, X, and Y. And we have the symbol for that, which is AC with an underline below it. So A is a subset of B. And you have to take note that a subset can be equal to the set. That is, a subset can contain all the elements that are present in the set. I'm going to show you an example. We have A, and I'm going to put 1, 2, 3. And I'm going to put B as also 1, 2, 3. A is a subset of B, and we can also say and B is a subset of A. Next, we have cardinality, which is just a fancy way of saying how many elements are in the set. So what you want here are finite sets, meaning countable sets. We have set A, which has all of these numbers. Then we have a notation. So the number of elements in A is how many? 1, 2, 3, 4, 5, 6, 7. 7. So there are 7 elements in the given set A. Let's do an activity before we end. So we have here, which of the following are null sets? Remember, a null set are sets without any elements. We have here primes that are divisible by 7. Remember, prime numbers are divisible by 1 and itself. And we have 1 here, which is just 7. So this is not a null set. We have Asian countries that have won gold medal in the Olympics. We have a lot. So this is not a null set. Whole number between 17 and 18. Is there a whole number between 17 and 18? There's nothing. So it is a null set. So I'm just going to put the check mark there. We have 0 right here. Even though 0 represents nothing, it is a placeholder. So this is not a null set. And of course, E is absolutely a null set. Number 2, which of the following sets are finite or infinite? So I'm just going to put F as finite and I for infinite. So we have here A, B, C, D, E, which continues the pattern until we have X, Y, and Z. This is finite. It has an end. We have 2, 4, 6, even numbers. It continues on. So this is infinite. We have factors of 12, meaning if you get 12, what are the common factors of it? Those are finite because eventually you would get 1. Multiples of 12. This one is 12. Then we have 24. Then we have 48. And then so on. This is infinite. Prime numbers. We have an infinite amount of prime numbers. This has already been proven. We have number 3. In the following set of objects, sort out the odd element. A, we have boat, car, airplane, petrol, and bus. I believe all of these are different modes of transportation, and petrol are the ones that fuels it. So petrol is the odd element out. B, we have deer, chicken, cow, pig, and sheep. You could argue that chicken, cow, pig, and sheep are farm animals, and deer is a wild animal. Or you can argue that all of these are walking in 4 legs except for the chicken. I'm going with the farm animals. These type of questions are the ones that I don't really like because it's kind of subjective. C, we have quadrilateral, square, pentagon, rectangle, parallelogram. Let's just count how many sides there are. Quadrilateral, there's 4. Square, there's 4 sides. Pentagon, there's 5 sides. Rectangle, there's 4 sides. Parallelogram, there's also 4 sides. So the pentagon here is the odd element. D, we have 1, 3, 5, 7, 9. I think we all know that these are all odd numbers, which brings us to 12, which is an even number, and 13, which is an odd number. So that 12 is the odd element. E, we have 2, 3, 4, 8, 16, and 32. I believe 2, 4, 8, 16, and 32 are multiples of 2. So the 3 here is the odd element out. That's it. End.